The second part of transportation problem is known as assignment model. مشاكل التعيين. Assignment problem is a special type of linear programming problem where the objective is to minimize the cost or time of completing a number of jobs by a number of persons. Assignment problem is the kind of transportation problem. Its main function is to minimize cost of assignment certain number of machine to a certain number of jobs. To assign a certain number of computers to a certain number of labs, or how to assign 4 managers to manage 4 projects. So the issue of this model is about how to take an optimal decision which leads to minimize the cost of assignment. Of J tools to I jobs. This problem should be represented by matrix where the rows of this matrix, for example, reflects the tool and column reflects a jobs. The main condition that the number of tools should equal to the number of jobs. The main is to remind you that assignment model is a kind of transportation problem. And it has 2 functions: easier to maximize profit or to minimize cost of assignment. But the main job of assignment problem is to minimize the cost of assignment. هي أحدى أنواع مشاكل النقل، والهدف الأساسي من نموذج التعيين هو تقليل تكلفة تعيين أداة معينة أو عدد من الأدوات لتنفيذ عدد من المهام tasks. كمثال، كيف نعين 5 مدراء لتنفيذ 5 مشاريع؟ how to assign 5 managers to implement 5 projects. Notice that the number of managers 5 and the number of projects 5. How to distribute these 5 managers among these 5 projects? Ahmad manager to implement the project of water. Hindi to implement the project of health. Ali to implement the project of education, etc. etc. Now, let's move to the second slide to introduce in depth what stands behind the assignment model. Introduction and formulation. The assignment model is a particular, as mentioned before, is a particular case of transportation problem where the number of jobs, origins or sources are equal to the number of facilities. The objectives is easier to maximize the total profit or to minimize the total costs. The model is useful in solving problems such as assignment of machines to jobs and managers to projects The main characteristic of this model are following. Assignment problem is a special case of transportation problem. The objective is to assign a number of resources to an equal number of activities so as to minimize total cost or to maximize total profit. The problem of assignment arises because available resources such as men, machines, etc. have varying degrees of efficiency for performing different activities. The assignment problem deals with allocating various resources, items to various activities, receivers, on a one-to-one basis. For example, the number of operations are to be assigned to an equal number of operators, where each operator performs only one operation. For example, suppose an accounts officer has 4 subordinates and 4 tasks. The subordinates differ in efficiency and take different time to perform each task. If one task is to be assigned to one person in such a way that the total person hours are minimized. The problem is called an assignment problem. The assignment problem is a special case of transportation problem. It is not solved using the methods as simplex. We use another method called easier enumeration methods or Hungarian methods. After studying this unit, you should be able to formulate the assignment problem or an assignment problem to determine the optimal solution of assignment problem using the Hungarian or enumeration methods. Obtain the solution for a special case of assignment. Now, this is a simple introduction which meets the requirements of our course. We will make stress on two only models: enumeration methods and the Hungarian methods. Enumeration methods and the Hungarian methods. Johnson method. The main is mentioned as we articulated before. We will use only two methods of assignment. The very simple method is known as enumeration method. And the second is Hungarian method. Let's see what do we mean by enumeration methods and how to be applied. In particular, this is a very simple method to assign not more than 5 jobs or not more than even 4 jobs to not more than 4 tasks. A list of all possible assignments among the given resources and activities is available. Then an assignment involving the minimum cost, time, distance, or distance is selected. Find the optimal assignment given the following assignment problem using find the optimal solution for the assignment problem using the complete enumeration method. طريقة العد الكامل. Now, 3 machines against 3 jobs. machine A, machine B, machine C. These three machines have to implement three jobs. 1, 2, 3. The condition of application this method is satisfied: number of rows equal number of columns equal 3. Accordingly, we can assign the using of the factorial technique. But before that, each cell consists of a certain cost. The intersection cell between 1 and A machine has $19 as the cost. What that means? If we assign machine A to implement the job 1, this assignment, it costs $19. If we assign machine A to implement job 2, it will cost $11. If we assign B to job 2, then it will cost $7. If we assign C to implement job number 3, then it will cost $13. Now, but if we assign machine A for job 1, then we will delete the mission of machine B and machine A to implement machine or jobs 1, because already job number 1 is directed to machine A. Now, then the remain opportunities to machine B, easier to implement job 2 or to implement job 3. So if we assign machine B to apply job 3, then it will cost us $11, and the remaining job to be implemented is job 2. Now it's free. So then job 2 will be assigned to be implemented by machine C. This is randomly. This is randomly solution. Randomly solution. In order to avoid the random solution, then we will use the factorial techniques. Once the number of rows equal the number of columns equal 3, then the factorial 3 equal 6. 3 times 2 times 1 equals 6. So we have 6 alternatives to determine the minimum cost. Each of machine A has 2 alternatives, machine B has 2 alternatives, and machine C has 2 alternatives. The sigma of these alternatives, the sum of these alternatives, are 6 alternatives. 6 alternatives. Now, for example, now we are going to draw in a special table which consists of 6 rows. Each 2 rows belongs to one machine. Now, assume that the number of machines are 4. Then the alternative should be 4 times 3 times 2 times 1. Then we will get 24 alternatives. The factorial, the factorial of 4 is 4 times 3 times 2 times 1. 24 alternatives. So we are going to draw 24 rows. Assume that the number of rows equals the number of columns equal 5. Then we are going to find factorial 5, which is 5 times 4 times 3 and times 2 times 1. 120 alternative. 120 alternative, which is so difficult. That's why we call and we describe the enumeration method as infant model. Very simple model, but it gives a great imagination of how to use the assignment model. Okay, let's move to the second slide to explain how to find an optimal solution. Actually, how to find a minimum cost, which indicates that we got an optimal solution. Okay, as we mentioned before, the alternatives are 6. Now, alternative 1. Alternative 1. We are going for this alternative to assign machine A to apply job 1 and B to apply job 2 and C to apply job 3. Return back to the previous table. If we assign A to implement 1, then the cost is 19. If we apply B to 2, then it costs 7. If we assign C to job 3, then it costs 13. The total is 19 plus 7 plus 13 equal 39. The next alternative, A for 1, B for 3, C for 2. Now, again, if we assign A to 1, it costs 19. If we assign B to 3, it costs 11. If we assign C to 2, it costs 5. 19 plus 5 plus 11 equals 35, etc. we applying these assignments using the previous table. Take for example alternative 4. If you assign A to implement the job number 2, then it costs 11. If we assign machine B to implement the job number 2, also it costs 11. Job number 3, sorry, it costs 11. If we assign C to implement job 1, also it costs 11. The total cost is 33. Now, the harvest of this calculation gives the least cost of assignment. The least cost of this operation is 33. So, in order to take an optimal decision, we have to assign machine A to implement job 2 and machine B to implement job 3 and machine C to implement job 1. So the combination of assignment is A2, B3 and C1. If we are following this assignment, then we will get the least cost of assignment, which is equal 33. This the application of enumeration model in its simple way. In reality, it's difficult to implement this model in the large business, where the alternatives more than thousands. But its significance is to show how to use the simple model, or how to take an optimal decision among various alternatives. Hungarian model. The Hungarian methods is a computational optimization technique that addresses the assignment problem in polynomial time and for schedules following primal dual in 1955. Harold Kong used the term Hungarian methods to honor two Hungarian mathematicians, Denis Kong and John Egrivery. The Hungarian method is a simple way to solve assignment problem. Assignment problem is completely a degenerate form of transportation problem. طالعة منا منسوخة منا. The units available at each origin and units demanded at each destination are all equal to 1. This means exactly one occupied cell in each row and each column of the transportation problem. That is only n occupied cell in place of the required n plus n negative 1 equal to n negative 1. It's known as occupied cell. This is a Hungarian methods of how to find an optimal solution using the Hungarian methods. It's very simple methods. Steps to apply or for applying the Hungarian methods. Okay. If the number of rows are not equal to the number of columns and vice versa, then a dummy row or a dummy column must be added with zero cost elements. We need to make stress and remind you about the condition of implementing the Hungarian method. The condition states that the number of rows should equal the number of columns. Okay. Step 2. Find the smallest cost in each row and then subtract this smallest cost from each element in that row. The result is new matrix, and there will be at least 1 0. Logic. This is known as the row subtraction. In the new matrix, the matrix after the subtraction of rows, find smallest cost in each column and subtract this smallest cost from each cost element in that row, in that column. As the result, there would be at least 1 0 in each row and column in the second reduced matrix. Step 4. Then we are going to apply 2 steps after the confirmation of condition. Now, first we are going to ratify that the number of columns equal the number of rows. Then the first procedure, which is known as rows subtraction. What do we mean by subtraction of rows? to choose the smallest cost in each row and subtract this smallest cost from the remaining elements or cost in the row. New matrix is gotten. In this new matrix, we are going to choose the smallest cost in each column. Is known as column operation, column subtraction. We are going to choose the smallest cost in each column and subtract this smallest cost from the remaining elements or costs in each column. Then determine an optimal assignment as examine the rows successfully until a row is exactly 1 zeros is found. Box around the zeros elements as an assignment cell and cross out all other zero in its column. Repeat in this manner until all the rows have been examined. Proceed the procedure for the columns of the reduced cost matrix. Repeat the procedure for the column of the reduced cost matrix. This is very attractive method. Five. An optimal assignment is found if the number of assigned cells equal to the number of rows and columns. If a zero cell is arbitrarily chosen, then there may be an alternate optimum. If no optimal solution is found, then go to the next step. Draw the minimum number of horizontal and or vertical lines through all zeros. If the number of lines passing through all the zeros is equal to the number of rows, the optimum solution is attained. Otherwise, go to the next step. So, the number of lines should equal the number of columns and the number of rows. If so, this problem is said to be solved. The pointer of solution is the lines which cover the rows or columns which contains the minimum number of zeros. Application. Example 1. The assignment cost is assigning any one operator to any one machine is given in the following table. Machine, operator. Now, The matrix consists of 4 machines against 4 operators. Each machine should be assigned to one operator. The condition is satisfied. 4 machines and 4 operators. The cells inside this matrix contains the cost of assignment. For example, if we assign A to 1, then it costs 10. If we assign B to 2, then it costs 9. If we assign C to 3, then it costs 3. If we assign D to 4, then it costs 7. The requirement is to find the optimal solution using Hungarian methods. Remark, the red numbers represent the matrix, the body of the matrix. Now, this problem gives 3 machines and 3 operators. Each operator assigned to one machine, and each machine should be assigned to one operator, as we mentioned before, on the basis of 1 to 1. On the basis of 1 to 1. Now, we are going to apply the Hungarian methods using the previous steps or instructions. Subtraction or row subtraction, then column subtraction, then to draw the lines which will cover the rows of column which contains a minimum number of zeros. If the lines equals the number of columns or the number of rows, then we get an optimal solution. To reach the optimal solution means that the lines should equal, the number of lines should equal the number of rows or column. The expected number of lines is 4. The number of lines is 4. 4 equal number of columns, 4 equal number of rows, 4. Okay. The practices of row subtraction. خفض الصفوف وتنقيص الصفوف وطرح الصفوف. Now, referring to the given matrix, the cost inserted in the first row are 10, 5, 13 and 15. The least cost in this row is 5, least. refer to the given problem. Now we are going to subtract the smallest cost, which equals to 5, from each element of this row. Then 10 minus 5, 5 minus 5, 13 minus 5, and 15 minus 5. The result is 5, 0, 8, 10. Then move to the row number 2. Check your given problem. In the row number 2, the costs inserted in this row are 3, 9, 18, 3. Then the least cost is 3, should be subtracted from the remaining elements of this row. 3 negative 3, 0, 9 negative 3, 6, 18 negative 3, 15, and 3 negative 3, 0. Move to the next row, row 3. The cost inserted in this row are 10, 7, 3, 2. The least cost is 2. These 2 should be subtracted from the remaining cost. 10 minus 2, 7 subtracted by 2, 3 negative 2, and 2 minus 2. The result is 8, 5, 1, 0. The last row is consisting of cost 5, 11, 9, 7. The least cost in this row is 5. Then 5 should be subtracted from the remaining cost. Then 0, 6, 4, 2. As you see, each row, the first row got 1 0, the second row got 2 zeros, the third row got 1 0, and the last row got 1 0. At least, when we mentioned before that, at least row should get 1 0, except column number 3 has no 0. Of course, the number, now we are not going to apply the lines. We are going to jump to implement the second operation, which is known as column subtraction, using this matrix. We will apply the operation of column subtraction using the matrix after the row subtraction, not referring to the origin problem, referring to the problem after the row subtraction. Okay, put into account. We will deal only with new matrix, after the operation of the row subtraction. Okay, we are going to choose the least cost from this given matrix. Now, referring to the previous problem, just look to the previous problem and focus on the columns. Focus on the columns. Now, the least costs, we are going to choose the least cost in each column. For example, referring to the previous matrix, the least cost is in the previous is 0. So if we subtract 0 from the remaining cost, the column is remain as it is. Also, this case is applied to the next column and to the last column, except the column 3. The least cost in the column 3 is 1. This one should be subtracted from the previous, from the other cost. Then we will get 7, 14, 0 and 3. Now each column and row has minimum number of zeros. Now the next step, we are going to cover using lines to cover the rows or the columns which consist of zeros. So we can, of course, easier column 1, column 2, column 3 or column 4, or row 2, row 3 and column 1 and column 2, whatever. Now the number of lines equals the number of columns equals the number of rows equal 4. Then the assignment is said to be optimal. Respectively, machine A should be assigned to operator 2, cost equal 5. Machine B to problem or to operator 4, cost equal 3. C to 3, cost equal 3, and D to 1, cost equal 5. The total cost is the summation of the costs 5 plus 3 plus 3 plus 5 equals 16. So when we assign machine A to operator 2 and B to 3 and C B to 4 and C to 3 and D to 1, we will get the minimum of the cost of assignment for machine to 4 operators. This is what is known as the Hungarian model. In its, of course, simple way.